Our next transformation is going to be reflections. We are reflecting across the x-axis if the negative is in front of the function, so negative times the function. We're reflecting across the y-axis if the x itself is negative. So negative f of x reflects over x, negative x reflects over y. So let's look at an example of that. So here I've got a graph. The graph is here, and I want to first reflect it over the x-axis. That means each one of these points, the y becomes negative. And so here I have 0, 0. Well, that's just 0, 0. 1, 1. So the point's 1, 1. Reflected over x becomes 1, negative 1. And the point here is 3, 3. So that's going to become 3, negative 3. And then this point is 4, 1. So that's going to become 4, negative 1. So reflected over the x-axis is my graph there. Now this says to reflect it over the y-axis, meaning the x values are going to change. So 0, 0, still 0, 0, but 1, 1 becomes negative 1, 1. 3, 3 becomes negative 3, 3. And 4, 1 becomes negative 4, 1. And so this is reflected over the y-axis. So here's a summary of all of our transformations. And then down here at the bottom is the order in which they expect you to perform these transformations. So notice that the first thing you're going to perform is a horizontal translation. Then do your stretches and shrinks. Then reflect. Then do your vertical transformations, which are your up-down shifts. So as you're following through these examples in the textbook and these practice problems, refer back to this order as you are performing your transformations. So here is an example that's already worked out. So we're going to graph the function defined by f of x equals 2 times the absolute value of x plus 1 minus 3, parent function being the absolute value function, which is the v. Okay. If I want to perform these in the correct order, I'm going to do the horizontal shift first, which is left 1 unit. Then I'm going to do the stretch, which in this case is a vertical stretch by multiplying the y values by 2. And then I'm going to move everything downward. So my result is this blue function here where I have shifted left 1. So let me just take a point, for example. Left 1, so I went left 1. Then I stretched by 2, so it's at 1 and now it's going to be at 2, and then I shifted down 3 and ended up on the graph. So let's do one. So let's look at what we've got here. And so horizontal shifts come first. So this is telling me, if you think about this, this is negative x plus 3. So the first thing I'm going to do is I'm going to move left 3. Then I got to do my stretches and compressions, which I have a vertical, we have a vertical stretch by 1/2. That means all my y values are getting multiplied by 1/2. Then I need to reflect over the x-axis because that is times the parent function. And then I don't have any other shifts, so that's it. I'm done. Those are my shifts. I don't have a number 4. So I'm going to move left 3. Then I'm going to stretch by multiplying my y by 1/2. And then I'm going to reflect over the x-axis. So I'm going to do it on this graph since it's already got the parent function on there. And I just think it would be easier if I used that one. All right, so let's see if we can do this. So 0, 0. Start here. 0, 0. I need to move that left 3. So 1, 2, 3. That puts it there. Stretch by 1/2. Well, if the y value is 0, multiplying by 1/2 doesn't make a difference, and reflecting. So there's my first point. So let's look at this point, 1, 1. So I'm going to move it left 3. So that puts it there. Then I need to stretch by 1/2, which means I'm multiplying the y values 1/2, which puts it right there. And then I need to reflect it, which puts my final point right there. Let's find another point, 4, 2. So right here, let's left 3, so 1, 2, 3. Multiply the y value by 1/2, puts it right here at 1. And then reflect puts it at -1. So my new graph actually looks like that.